1942. American scientists get word that Nazi Germany may already be building an atomic bomb. Einstein signs a letter to the president. 6 words matter more than the rest. Uranium could end the war. A desert outside Los Alamos is chosen, remote enough that if it goes wrong, no one nearby will know. Thousands of workers arrive without knowing what they're building, only that it has to be first. Oppenheimer is chosen to lead them, a physicist with no experience running anything this large. Every calculation says it's theoretically possible. Nobody knows yet if it's actually buildable in time. Germany's own atomic program, it turns out, is further behind than anyone in Los Alamos realizes. But nobody in the desert knows that. The fear of losing the race is the only thing anyone can measure. By 1945, Germany surrenders first. But the project doesn't stop. Japan is still fighting. Building the bomb on paper is one problem. Getting enough pure uranium is an entirely different war. The process is agonizingly slow. Months of work produce only grams of usable material. Engineers redesign the separation process 3 times. Each fix creates a new bottleneck somewhere else. Washington wants a timeline. Los Alamos keeps giving the same answer, as fast as physics allows. A second path opens: plutonium, bred inside a reactor instead of refined from ore. It's faster, but nobody has ever built a weapon out of it. Every step is a first draft. A design flaw is caught just in time. The plutonium core won't detonate the way anyone assumed. The fix works, on paper. Implosion, not a simple gun-type trigger, is now the only way forward. By mid-1945, 2 years behind the original hope, they finally have something ready to test. July 16th, 1945. New Mexico desert, before dawn. The device sits alone atop a 100-foot tower. Scientists lie flat in bunkers miles away, welding goggles on, waiting for a countdown that feels endless. 0. The switch is thrown. Everyone braces for a light brighter than the sun. Nothing. A dull flash. A weak shockwave. Then, silence, and a tower still standing, half collapsed. A fizzle. The implosion lenses didn't compress evenly. The chain reaction never truly begins. Oppenheimer says nothing for a long moment. 2 years of work, and the desert barely even shook. The generals watching from the bunkers exchange a single, unspoken look. This changes everything. A telegram is drafted for Washington. It doesn't say success. It says, further testing required. In Washington, that telegram lands on a desk already counting the cost of $2 billion spent. Congress, already skeptical of a secret project that swallowed $2 billion, demands answers. General Groves, who ran the project, is asked a question with no good answer. What did we actually get? Some senators call it the most expensive failure in American history. The word failure sticks. Los Alamos scientists are recalled to Washington. Some are quietly reassigned to other war work. Oppenheimer fights to keep a skeleton team together, insisting the design flaw can still be fixed. He's given 6 more months and a fraction of the original budget. No margin left for another mistake. Meanwhile, the Pacific War grinds on without waiting for anyone's timeline. Military planners start drafting an alternative, one that doesn't depend on a bomb that might never work. The plan has a name already: Operation Downfall, and it's about to become the only option left. Without a war-ending weapon, the strategy reverts to what it was before anyone dreamed of the bomb. Firebombing campaigns intensify over Japanese cities, the only pressure left to apply. Japan's leadership, watching their cities burn, still refuses to consider surrender an option. Civilian militias are armed with sharpened bamboo spears, told to prepare for an invasion of the home islands. American commanders estimate the coming invasion could cost hundreds of thousands of lives on both sides. Meanwhile, Los Alamos scientists work in near total silence, trying to fix the flaw before the invasion date arrives. A second implosion redesign is finally ready, but there's no time left for another full-scale test. The invasion fleet is already gathering. Whatever happens next, it happens on the battlefield, not the desert. November 1945. Operation Downfall begins. Kyushu's beaches are far more defended than anyone in Washington expected. Soldiers wade ashore into a wall of resistance that intelligence reports never fully predicted. Kamikaze pilots, held in reserve for exactly this moment, are launched by the hundreds. Offshore, ships that were supposed to be safely out of range are suddenly not safe at all. By the end of the first week, casualty numbers already exceed the entire Iwo Jima campaign. In Washington, the president is handed casualty projections that keep climbing with every incoming report. Back in the desert, the redesigned device is finally, quietly ready. But the invasion isn't waiting for it. It's flown to the Pacific anyway, not to end the invasion, but to try to shorten what's left of it. The war that the bomb was supposed to end early is now the war deciding whether the bomb even matters anymore. The modified bomb is dropped on a military staging area, and this time, it works. But it isn't enough. One bomb dropped mid-invasion doesn't shock a government into surrender the way an early one might have. The ground war on Kyushu grinds into its third month, with casualties nobody in Washington wants to publish. A second invasion, aimed at Honshu near Tokyo, is now scheduled for the spring of 1946. 3 more bombs are quietly built and shipped west. No longer a secret weapon, just another artillery shell. By early 1947, exhaustion, not a single decisive weapon, finally forces Japan's government to negotiate. The war ends nearly 2 years later than it did in our history, and at a far higher human cost. Millennials who survived in our timeline never make it home in this one. The bomb that was supposed to end the war quickly, instead becomes proof that it almost couldn't. In our history, the bomb's shock became a warning the whole world absorbed. In this one, it never quite lands that way. Nuclear weapons exist, but they arrived too late, too gradually, to freeze the world in fear of them. Without a single terrifying flash burned into global memory, conventional armies stay the main measure of power. The Soviet Union, watching America's program stumble, quietly accelerates its own, with fewer setbacks. By the early 1950s, Moscow may be the first to field a reliable atomic weapon, not Washington. Without mutual deterrence built in from the start, the two sides drift toward proxy wars fought directly, not carefully. Without the doctrine of mutually assured destruction, planners on both sides start to see limited nuclear use as survivable. The line that, in our history, no nation dared cross again after 1945 was never drawn this clearly at all. A weapon meant to end one war ends up quietly reshaping how every war after it gets fought. By the 1950s, the bomb finally works the way it was always meant to. Reliable, terrifying, and everywhere. But it arrives into a world already reshaped by direct conflict, not one held together by the fear of using it. The doctrine that kept the real Cold War cold, mutual guaranteed destruction, is built here almost as an afterthought. Oppenheimer, older now, is asked whether the delay changed anything. He says it changed everything, just not the ending. Millions more died, reaching the same destination the real world reached in a single flash, twice, in August 1945. History calls the bomb's success in 1945 a turning point the world feared. Chronist X calls the delay the price of not fearing it soon enough. In our history, one flash ended a war and defined a century of careful fear. In this one, it took a fizzle in the desert, 2 more years of war, and a colder peace to get there instead. One fizzle in the New Mexico desert, and the whole shape of the modern world, quietly, permanently, bent. What else did one failed moment quietly reshape? Follow for the next divergence.